Hi guys, I'm Siddharth Gavas and welcome to my channel Learn with Tech Pro. This is my first video on this channel and basically this is my first YouTube channel. So why I decided to start this channel and what was the motive behind it? So I'm a software engineer by passion and profession, and as I learn things as I progress in my career, I would like to share knowledge and things with you guys, and wish to receive feedback from everyone. So if you guys have any comments or feedback, please mention it down in the comment section. And yeah, that's all about it. So let's get started with this video. So this video is about a personal project that I have worked on using Spring Boot and RabbitMQ. It's basically a simple notification service that will just push the events to web clients and mobile clients. So in this video, first I'll be talking about the high level design, as in what was my approach to use RabbitMQ and to build this notification service. Then I'll be talking about low level designs and a code walkthrough, as in how I use Spring Boot to build out this notification service. And I'll be also presenting a little bit of a simple kind of a demo for this notification service. So for those who are new to Spring Boot and RabbitMQ, so what is the Spring Boot and RabbitMQ? So Spring Boot is a framework in Java that allows you to build web applications, event-driven services, or basically any microservices. And RabbitMQ is a message broker that has this queues, the message queues, and message exchanges. So using these two components, we can build an event-driven system such as notification service. So first, let's talk about the high-level design on how we used RabbitMQ and Spring Boot to achieve all of this. So basically, it comes down to the problem of producers and consumers. So if we talk about a notification service or the push notification service or the push notifications in general, then the producers are any systems that will generate events, or it will generate notification. It could be any abstract service. We don't have to know the details of that service. We just have to know that it's a producer that will generate an event, and that's a source of like an event, and eventually it will those notifications will reach down to your web client or your web application or your mobile application. So here you can see that we have couple of mobile clients that calls and that connects to my push notification gateway or the notification service using an HTTP endpoint. Now, this HTTP endpoints are not the usual HTTP request and response, where we send the request and we immediately get the response, and then the HTTP or the TCP connection is closed. Rather, this not endpoints will generate something called as a server-side events, or SSS or SSE. Here, what happens is basically once the connection is opened on a web server, the connection is kept closed, and server will keep on pushing or keep on sending notification updates or events or responses to the mobile clients or the web clients, and this is like a stream of responses that's sent to the client. So basically this part of the communication where the notification service pushes it to the mobile or the web client is achieved using something called as a server side events. And Spring Boot has a support for the server side events, and it allows us to create REST controllers which produces this server side events. One thing to note about server side events is that its content type is always text event stream. So this is the content type of uh, the REST controller, and the application then or the web client then knows that it has to keep the stream open or the connection open, so it keeps on receiving the server side events. push notification gateway is basically a Spring Boot component that we use to get messages from the RabbitMQ and pass it down to the like respective web clients. So when web clients call the REST APIs or the REST controllers, they pass this unique ID, which could be a unique to a consumer, it could be a unique to device, or it could be unique to a user account. So the implementation of that is specific to your use case. But here, what we did is that you just pass me a unique ID, and based on that ID, you get the notifications delivered to your client. Then we have a Rabbit MQ, which is a message broker that takes care of delivering the messages from the producers to the consumer. So in this case, push notification gateway is kind of an intermediate consumer that will deliver messages to web clients in the end, and the producer is any generic system that just produces some message. So what happens here is that a producer will generate some message, and that message the RabbitMQ takes care of delivering it to the this push notification gateway. So there are few concepts which are there in RabbitMQ that helps us achieve this. Basically, there is a concept of queue and exchange and queue types. So here you can see that whenever I create whenever I create a connection, or whenever I call in the REST and controller, I create one queue, like a one queue is created in RabbitMQ, such as subscription dot the ID. So let's say I tomorrow a new device comes with ID, let's say 2, then a new queue will be created in RabbitMQ. So each queue in the RabbitMQ is associated with one device, or we can say one subscription. So what is this queue? The queue is basically first in first out kind of a simple queue that buffers messages or the events received from the producers, and then pushes it to the notification gateway, which eventually pushes it down to the web client or the mobile client. Then each subscription has a binding with something called as an exchange. So what is this exchange concept in RabbitMQ? So exchange is something like queue, but it does not buffer the messages. Rather, what it does, it whenever it receives a message from a producer, it will direct it to the respective one or the more queues. Now how it routes this messages from now how exchange routes this messages from within itself to the other queues is dependent on the type of the exchange that we define. So there are different types of the exchanges, such as fan out, direct, or topic. So here we used a type called as the fan out. By the way, the notify.all is just an exchange name, and fan out is the type of the exchange. So what fan out type exchange type does is that whenever it receives a message from producer, it will like whichever queue that is bound to this exchange will receive that message. So let's say message m1 is passed to exchange, then there will be n copies of this messages will be made, and it will be pushed to the queue. Now via queue, what we do is that since each queue is associated with each client, the messages from this queue is then consumed by the push notification gateway and delivered to its respective web client or the mobile client. So this is how the overall design of the whole this push notification service is. The thing is, we can scale this independently. Like we can scale the push notification gateway independently, so it receives more. It can handle more connections from the devices, or it can handle multiple connections from the users. We can individually scale the RabbitMQ broker server. It's a distributed broker, so we can create the number of the queues that we create is is bound by the resources, or the the compute resources that we get. this is the overall architecture of the notification service that I developed. So now I'll be talking about low-level design, which we use to build out this push notification gateway. So the RabbitMQ broker is just another server that has started locally using its Docker image. So the Docker image is readily available on the Docker Hub. You can just start one a simple RabbitMQ broker on your local machine. And this whole part from the subscription controller to the push notification service is basically my push notification gateway. So at the code level, what I have done is I've defined one subscription controller, which is basically a REST controller. So I defined one REST endpoint there. Then there is a push notification service which manages this connection with the clients, the web client or the mobile client, and takes care of pushing the events to the web clients or the mobile clients. So what happens when a new connection is made is that whenever let's say there's a mobile client that calls this push notifications endpoint with some unique ID, then we call this get notification stream, and where we pass this ID of the and this method belongs to the push notification service. So what this method does is basically it declares a queue in RabbitMQ with this ID. It creates an if the exchange is already created, then it reuses that exchange, and if it's not created, then it will simply define a new exchange, and it bounds that queue to that particular exchange. So we talked about exchange a few minutes back, where it will route that message to all other queues. So with each connection, what we do is that we create a kind of a stream, and in that process of creating stream, we declare queue, we create exchange, we create binding, and then finally, what we do is that we create a queue listener. Now, queue listener is basically like a consumer for a particular queue. Like each queue has a consumer. What that consumer does is in this push notification gateway, it consumes the message from the queue and pushes it down to the web client. So the next flow is that from the get notification stream method, what we basically do is that we return a flux. Now flux is a reactive, it's a part of a reactive framework that's a part of Spring Boot web flux. So it's like RX Java. They're like flux is like it's a reactive stream of events or the messages. So push notification service basically returns this flux with a queue listener as a producer. What that means is that this flux is driven by the this queue listener. Basically, this flux, whatever this queue listener gets the messages from the RabbitMQ, it will push it down to this flux, and eventually from the this reactive flux, the events we create a server sent event, and that is sent to the mobile application or your web client. So at the code level, we use this feature of, we use a reactive framework or project reactor. We use server sent events, and we used RabbitMQ client to connect to our RabbitMQ broker. Further breaking down our design, we can see there are a couple of components or the classes that we have used or created to achieve this whole flux and this whole reactive stream. So simple message listener container is basically it's a class that's provided by the RabbitMQ client library, which allows us to create a consumer for a particular queue. And what this message listener does is that it takes one object as a delegate object to which these events are pushed, and we can define which method to call of this delegate to consume this event. So all the events from the queue to which this container is listening is pushed to the a push notification emitter. Now, push notification emitter is an interface that I created, which extends from this consumer of Flux Sync. So Flux Sync is basically like a source of the a flux to which we can push events, and that flux of events will flow down it eventually to um, the web client. Uh, Now, yeah, so the push notification emitter, from that interface, I created a concrete class called as a default push notification emitter that basically has this, a method called, has an implementation for this method called as a emit. So when we called its emit method, basically that event or the string event or simple message event is pushed down to the flux. Now, when we call the next dot event, it is like it pushes down one notification to the flux stream, and since this flux stream is returned to the web client receives this series of notification. Until and unless we close the connection, this flux of streams will be kept open, and your mobile client or your web client will keep on receiving this notifications from the producer to RabbitMQ to your push notification gateway, and then finally to the respective your mobile device. So now let's get a deeper dive into this code for push notification gateway. So let's start with the subscription controller or the REST endpoint to which my web clients or the mobile clients will be opening their connections, or connecting it to my gateway to fetch the events or get the stream of events. So we have defined this REST controller. This is like a normal REST controller of the Spring Boot. It's a get mapping. We can see that it returns a flux it returns a flux reactive stream of a server sent event. Now, server sent event is a special object or the class in Spring Boot that returns a text event stream kind of content type of objects. And then we take a path variable, which is basically my unique ID. It could be a device ID, it could be a user ID, for which which listens to this notifications. And then I have created one push notification service that will basically get me the stream of this flux stream of this events. So here you can see that get notification stream, it returns the flux of strings. Now my events, I have modeled it to be a simple string messages. So once I get that stream of events, what I do is that I map it to server sent event, where server sent event it has specific structure, like it has some IDs, it has some comments, or it has some data. So my message is it's wrapped under the data field of the server sent event, and there's an event name for the server side event, so I just call it notification hyphen event, and there's this whole stream of the server sent flux stream of the server sent event is sent to the client, and the client knows to keep its connection open, since it receives a content type as text event stream, and it keeps on listening to these events which are pushed by the server. So let's get deeper into this push notification service. So it's a simple interface. It has this get notification stream method, and if you open its implementation, then here we see that what we do is that whenever we receive this subscription ID from the client, we create a queue, and we bind that queue to a exchange. So in the declare and bind queue method, you can see that I've defined one queue with the name as a subscription dot the ID. So a queue will be created with the name subscription dot ID in RabbitMQ, and then I'm creating one exchange. This is like, if it's already defined, then it has no effect, but if it's not, then a new exchange will be created called notify dot all. Here I say that it's a durable queue, as in when all the connections are closed or all the queues are deleted, the exchange is not deleted. So by default, exchanges and the queues are durable. Then what I do is, here I declare the exchange first, then I declare the queue, and then I bind that queue to the exchange. So here you can see I have created one bind of, like, I bound that queue. Sorry, I bind that queue to the exchange. Now here we don't need to define a routing key, because the exchange we defined is a fan out exchange. Basically, whatever messages it receives, it will just pass it down to all the queues to which it is bound. So that's basically declaring the binding. So this is how we created. This is how we create a declare. We create queues in RabbitMQ and bind it to a exchange. Once that is done, what I do is I create one emitter called the default notification push notification emitter. Basically, this is a kind of a wrapper object that takes care of passing the event from the consumer of the queue to the flux, to which returns that event to the client. So here you can see that we created one event emitter, then we create a listener. A listener is basically a queue consumer. So you can see that in that queue consumer, we set a delegate. So delegate is like whatever the events which are received by this listener are delegated to the event emitter. And which method do we called of the which is called of the event emitter is the emit method. So if you open this default notification emitter, you can see that there is an emit method defined here, which basically receives that event and pushes it to the sink. Now the sink is basically the flux sink, which is like a, the starting point of the flux, which pushes that event throughout the flux stream. So when we do sync dot next, that event is pushed to the flux stream, and then it reaches to the web client or the mobile client. Once the message listener is created, we create a container which just wraps this event emitter and listener for a particular queue. So this is like a consumer that we create, or the container consumer that we create for a particular queue. And once that container is created, we just store that container in this service class in a map, so that the consumer is, like, alive, and consumer is not basically stopped when the connect this whole function calls exits. uh, then here we can see that we create a stream of this event emitter. So event emitter is basically a flux sink. Basically, it's in like a source of that flux, and that source we return it from this method, which is passed to the client. Now, here what you see that we have defined something as a do on cancel. So basically what this means is, whenever the connection is closed from the client side, this method is called do on cancel. And when like a connection is closed, the flux is basically destroyed, like a subscription is closed. So this do on cancel is method is closed, and basically we stop the consumer which we have defined, and remove it from our context. So this way we ensure that the consumer that we define for our RabbitMQ queue is closed once the connection of the mobile client with the push notification gateways ends. Then let's talk about this default notification emitter. Here you can see that we have an emit method and we have an accept method. So this accept method is belongs to this consumer flux sync, which is used to create the flux streams. And in the accept method, what we see that whenever whenever a subscription is made to the Flux stream, we store this sync in a class, and whenever an event is received, basically the emit method is called, and that event is pushed to this sync. From the sync, it goes to the Flux, and from the Flux, it reaches to our web client or the mobile client. So we had a brief overview or code walkthrough of how the push notification gateway is implemented. Now let's move to a small demo where I'll be just showcasing this push notification gateway by just opening two connections. So basically, I'll be simulating the clients using my Postman as my client. I'll open a connection to my push notification gateway using this endpoint with these two IDs, one and two. So this basically means that these are the two separate web clients or the mobile clients. Then from the RabbitMQ's admin panel, I'll be pushing a message to an exchange, and from that exchange, the message will be passed to the queues, and from the queues, it will eventually come down to the postman's. It will come down to the postman client. So as you can see, I have already started RabbitMQ server on my local Docker container environment. The steps to start this container, I'll attach an README file of this GitHub repo where I'll upload this push notification gateway. Let's start our push notification gateway application. So my push notification gateway has started. Now let's open. Yeah. Now here you can see my notification. These are the two web clients. So and this points to my local push notification server. So I'll just open this connection. As you can see, even in the logs, we have it prints that we have received the subscription, or we have received the connection, or we have received the subscription. And this basically means that the queue has been created, and the exchange has been created in the RabbitMQ server. I'll also open the second connection, or let's just do one thing. Let me just go to my RabbitMQ admin panel, and okay, I think what had happened is I was already testing the software's component. So the queues are already created and durable. Let's just do one thing. We'll delete this queues. So I have already deleted my previous queues and exchanges that were created. Now what I'll do is I'll open, now you can see that there are no queues created in Rabbit MQ. Even in the exchanges, there are some default exchanges, but there is no exchange that we define in our code base, that's notify.all. So what we'll do is I'll open one connection here. So now connection is opened. Now you can see that a new exchange was created called notify.all, and its type is fan out. Now if we go to queues, you can see that we have already that a new queue is created, basically subscription.1. That's basically the ID that we passed in the REST endpoint. Let's open a second connection, and you can see here that even a second queue is created. Since the exchange was already created, that exchange notified all will be reused. And in the queues, you can see that there are two bindings here. The bindings are basically are basically like to which exchange this queue is attached. So there is something called the default exchange that's already always there for a queue, and here there's also a notify.all binding that's created to this particular queue. Now what we'll do is that we'll push a message to this notify.all exchange, and that message will appear in both of these responses. So you can see that this is my exchange notified at all. I'm giving this content type. This is your standard properties for the RabbitMQ message as a text plain, and I'm passing here the message hello world, and let's say publish message. As soon as we publish the message, you can see that this client has received that message hello world with the notification ID as notification event. Even the second consumer, or the second, let's say a client, even that received the same message. So if we again publish this message, this connection is still open. Again publish this message, this messages are received by both the clients. Now if we close this connection, basically that connection will be closed and only one client will be receiving the event. So this is how we implemented the whole push notification service using RabbitMQ and Spring Boot. I hope you found this video informative, and if you have any doubts or questions, or if you have some suggestions, then please feel free to comment down in the comment section, and please give your feedback. Subscribe to my channel and like this video and share this video if you find this informative.